Okay, on example 4, please note how this is written. All right, so the first thing that we need to do is we have this 3 minus sign. So many times they read it like that, but you need to make sure that the first thing you're doing is you're doing negative sign of 4x plus pi, and then plus 3. That's an equivalent way to write that so that we can see that it does have a vertical translation up 3 and a reflection. It's just much easier to see. Now the next thing we need to do is we need to take care of, this is not factored out. So this has to be factored so that we can see the order of the transformations and exactly what they are. So this is going to be negative sine of 4. And if you factor out, it would be x plus pi over 4. Picture distributing that back in, and you can see how that becomes 4x plus pi. Okay, so let's use that. So let's look at our transformations from that point. So the first thing it did was it moved left pi over 4. Have to do that factoring to be able to get the correct phase shift. So the phase shift is left pi over 4. Okay, and then the next thing it did, let's see here, had a horizontal shrink by 1/4. And so that's going to take our 2 pi period divided by 4 and get pi over 2 for our period. Then it also had a, let's see, a reflection over the x-axis. That's going to kind of change our direction. And it was moved up 3. And that's going to change our equation of our midline. It's going to be y equals 3. Our amplitude's 1 because it did not have a vertical stretch or a vertical shrink. Okay, so the first thing I'm going to do is I'm going to label this. We are going to need to move up 3. So here's our midline. Let's go ahead and highlight that first. We're going to have to label our x-axis also. I gave us blank graph paper on this one because I really wasn't sure what we needed. Okay, so up 3, and then let's see here. Our amplitude is 1. All right, so it's going to go from 4 as its highest point down to 2. Okay. Cool, that looks good. All right, and so then let's think about this. It is going to have critical points we do pi over 2 divided by 4 times the 4th, so every pi over 8. So what that tells me is it would be best to just make this be every pi over 8. So this would be 2 pi over 8, 3 pi over 8, 4 pi over 8 is like pi over 2, 5 pi over 8, 6 pi over 8, that's 3 pi over 2. 7 pi over 8, 8 pi over 8 is like pi, and so on. All right, and so then that'd be, just kind of mark those down. All right, so we've established our scale at that point. So if we go back 4, that's negative pi over 2. Back 8 is negative pi, and so on. See if I was thinking about that right. Okay, mark that one wrong. Sorry, guys. Okay, cool. So now let's go ahead and think about this. This is sine, and so sine, if it doesn't have a phase shift, starts on the midline, but it was moved left pi over 4. So that's going to move us left pi over 4 is here, so this is where it begins. Then normally sine goes up, but because of this reflection, sine is going to go down first. So sine's going to hit below, then back at the midline, and then back up, midline, below, and so on. And because we had our own graph paper, we kind of got to put our own spacing on there. The reason I don't give you blank graph paper throughout every single one is simply because if we can always just set the spacing along the x-axis or the y-axis just to be exactly what our critical points are, or exactly how much our amplitude is, we don't visibly see the stretch or the shrink that's actually happening. So that's why I like to give you the graph paper with it numbered, is because then I think it's easier to tell, oh, hey, look, this one's really stretched out horizontally or really shrunk vertically. It just kind of gives you more of a comparison. But in this case, this just fit what we had better. Okay, let's go look at example 5. All right, so here we have an equation, and it says the motion of a pendulum can be modeled by the function below. D is the horizontal displacement in inches of the pendulum relative to its position at rest. T is the time in seconds. So what that means is so if you picture like the pendulum like a clock, for example, And then when it swings this way, so then D is going to be your horizontal displacement, so how far apart it is right here. Okay, and so T is the time in seconds that it has like swung. So it's going to go back and forth. That makes it a cyclical function, which is why a sine or cosine function fit this scenario perfectly. Okay, so it says find and interpret the period and amplitude in the context of the situation. So remember that our period is 2 pi divided by b. So it's 2 pi divided by our b is 8 pi. So that equals 1/4. So what that means is that's the amount of time it takes for the pendulum to go back from far left to far right and then return is 0.25 seconds. So I said, when it wants us to interpret the time it takes the pendulum to move all the way right and left and return to its starting position is 1/4 or 0.25 seconds. Okay, and then the amplitude is 4. And so what that means, it's the maximum distance that the pendulum will be from its resting point. So at its farthest swing.